Welcome, everyone. My name is Crystal Hopper Myers, and I am our STEAM Pathways Assistant here at SWOCC. I'm really excited for you all to be joining us tonight. We also have online, our Curry campus is doing a watch party, and then various people around the world is tuning in. I know several have told me they were going to be joining us that way. And then even one of the local schools, I believe, is streaming it. So it's kind of exciting. So yes, this is our very first lecture for this fall term. We have kind of a busy schedule for this fall term lectures. Typically, it's not that busy, but we have a lot of really awesome talks lined up. So I'm kind of excited about that. Dr. Coiner is going to be here in just a minute, and he's going to introduce our guest speaker. And I just wanted to take a moment just to say thank you for being here. There's a lot of exciting lectures lined up. You can check us out on our website at SWOCC.edu. If you're on social media, Facebook, we have a STEAM Pathways, it's SWOCC STEAM Pathways Facebook page. We try to post it on the posters and local media as well to help with the word out. We do a lot of exciting things with our awesome SPEAR student research team, a lot of awesome programs happening with internships and K-12 and community outreach. So just kind of stay tuned on some things that you might be interested in. So at this time, I'd like to introduce Dr. Coiner.
Now I'm used to just projecting because I don't usually like to use the microphone, but as Crystal mentioned, I'm Dr. Aaron Coiner. I'm the professor of physics and engineering here at SWOCC, and I am glad to kick off our STEAM Pathways lecture series with, we called it an engineering topic, but as our guest will mention, design is interdisciplinary and it's multifaceted for everything. So it's an engineering topic in name only. It expands a lot of different things. We're happy to have Dr. John Reese, Professor Emeritus of Mechanical Engineering from East Carolina University, native Oregonian, but has traveled a lot and has settled back here in his retirement and was nice enough to wish to share his insights on design, the ultimate human activity. And with that, I will pass it off to you.
Thank you. Hi. See a lot of hands waving. Those of you in Brookings, those of you remote, wave at me. If you have a problem hearing me, you wave, and don't see any hands up, so I'm assuming you can hear me. All right. My talk today is design the ultimate human activity. And let's see if I know how to push a button. What is design? Well, ask 100 people and you get 100 different answers. Everyone has their own opinion and perception about what design is. And that's what we're here to talk about tonight, because we all design. I taught design and engineering. I'm an artist. I do design work in art. But it turns out we all design, no matter what discipline, we all design. And the problem you run across when you got people talking, yeah, but that's not design, or how does doing a painting impact doing an engineering design? It comes down to the question, are we talking about design or the application of design principles? I'm here talking about design, and design is universal to all disciplines. I'll talk a little bit more, give some examples in just a minute. But the key is the application of design. When we apply design to whatever specific project we're working on, that depends upon our discipline. That depends on the project. But design itself, the key points I'll be talking about tonight, apply to everyone and everything. So just a brief definition of design, and I realize for those of you catching this remotely, it may be hard for you to read the letters up in there. I tried to make them relatively large. I will be talking about everything, so it doesn't worry, don't try to squint too closely. I'll be saying everything you need to hear. Design in general is creating something new and ideally, hopefully something that's useful. I'll talk a little bit more about that in just a minute. But that's basically what it comes down to. Design is creating something new that fills a purpose, that has some point to it. Question: is design and engineering really the same as design and art? I do both. On the left is one of my abstract paintings. On the right is an artist's rendition of the Webb Space Telescope. Is design the same for those two incredibly different things? As an artist, is really design the same as engineering? The answer is yes. Brief commercial announcement. Pretty much everything I'm going to be talking about comes out of a book that I wrote. I asked myself a simple question a number of years ago. Can I be a better engineering design teacher because of my design work in art? And the answer is it depends on how I do it. So I researched it up writing a book. It's available on Amazon, and no, it's not a cheap book. I think last time I checked, it's about $65. So unless you're a passionate designer or you can write it off for tax exemption, it's probably not worth your money to do it. I hate to say that, but the truth is that's just the way it is. I'll get you what you need to know. Let's look at some quick examples of design to give you an idea how broad design is. A painting involves design. The new cell phone, the next generation cell phone, involves design. Next week's menu. Or I make my shopping list, think about what am I going to eat this next week, and think about the menu. That's actually a design process. Tomorrow's schedule. Particularly students with all this class and then pulling everything together. That is a design problem. Our personal and professional problems that we have, it's a design process to get solutions to them. Your life is a design project, and I'll talk a little bit more about that a little bit later. All right, let me give an overview of where I'm going to go with this presentation. Kind of hit some of the highlights, what I'm going to talk about, you know, the old Toastmaster thing. Tell them what you're going to tell them and tell them what you've told them. Well, I'm going to do that. The first thing we're going to talk about is the process called metacognition. It's a psychological term. It basically means think about how you're thinking. Most people have never sat down and done that. When I taught metacognition for my design classes in engineering, very few of the students had ever thought about how they were thinking. We'll get into that a lot more detail here very shortly. The next things I want to talk about is, it turns out design has three major steps to it, three major activities that everyone, no matter what discipline we're involved in, gets involved in. The first one is we have an ambiguous situation we need to resolve. We need to clarify that ambiguity to make sure our design solution actually works. Then we generate a whole bunch of ideas. A lot of ideas. And then we go through a selection process to pick one to implement. Then I'll speak just for a little bit on ways that anyone can enhance your ability to design. Some simple things that many of you are already doing, if not all of you are already doing. You just may not be consciously aware that doing these things makes you a better designer. And then I'm going to close a little bit with some of the biases we have that impact our design effectiveness. All right. What is thinking? Have you ever thought about it? See hands. How many of you ever have even heard the word metacognition before? A few hands. How many of you have an idea what it really means? It's a nice word, metacognition. Isn't that kind of cool sounding? Thinking in its simplest form is the processing of information, the mental processing of information. That's what we do when we think we're processing information. It turns out there's two fundamentally different types of thinking, and we do both of them. The first one is analytical thinking. Analytical thinking is the type of thinking we do when one thought leads to another, this because of this ergo that. There's a sequence, there's a pattern to how we think. We can predict our next thoughts pretty well based upon our previous thoughts. We can get there because there's a pattern to analytical thinking. The other type of thinking is intuitive thinking. It's non-sequential thinking. It doesn't follow a particular pattern, and we can't really predict our next thought based upon what our previous thoughts have been. It's non sequitur. It's like, oh, where did that come from? Banana cream pie. Could you have predicted that based on what I've talked about so far? Does it really make sense? And yet we all use intuitive thinking all the time. They're both important. It turns out that if you put EEG caps on your head and you do brain scan studies, that the people who have done this have identified that each of the two different types of thinking use different neural networks in the brain. They are truly different types of thinking. Analytical thinking uses what's called the executive control network in the brain, and intuitive thinking uses what's called the default mode network in the brain. They're truly different electrical networks that we use for these two different types of thinking. They're very real. Intuition isn't this woo-woo thing, and analytical isn't this. I consider analytical thinking a prison. We'll get to that. Things we don't really know what either of them are. We can identify some characteristics, but what really goes on, nobody's figured it out yet. Both are necessary for design. We don't need to understand what analytical thinking is. We don't need to understand what intuitive thinking is. We just need to know how to use them. And perhaps equally important, if not more important, we need to know how to identify which thinking mode we're in, and we need to be able to switch to the other thinking mode as appropriate. I'll spend a little bit more time on that in just a few minutes. We need to identify which mode we're in. Are we analytical? Are we intuitive? And be able to switch back and forth because they're both necessary for design. Now, a tougher question. What are feelings? Do you even know what they are? We all have feelings, part of being human, but what are they? And that gets into a tough question. It turns out for design purposes, there's two types of feelings that impact design that we need to be aware of. First of all, we use our feelings as information in our design process. How do we feel about something? Using feelings as information is oftentimes an intuitive type of judgment. We're passing judgment on something. We have some options. am I going to study for this class tonight, or am I go out with my friends and have a beer? I feel I'm going to do this. That's a judgment. We're using our feelings to make design decisions. The other type of feeling is how we feel, our mood. I'm in a good mood. I'm in a bad mood. It turns out our mood impacts our ability to design. Why we feel the way we do about these things, nobody knows. Lots of studies have been done, but you pull back the curtain and you look at the man pushing gears back there, nobody knows what feelings really are, or thinking for that matter. But yet, both types of feelings are important for design. It's important, like the metacognition. Be aware of how you feel and think about it, because you can change things that will impact your success design. Okay. Relax and open your heart. This is one of my paintings, not Shasta. We're going to shift gears here slightly for a second. Oftentimes, listening to someone talk with a PowerPoint presentation, for many people, put you in an analytical thinking mode. Oh, following along, yeah, nice and sequential, analytical thinking. Metacognition. Most of you are probably in analytical thinking mode, but some of you may be in intuitive thinking mode. Do you know which one? What I've found is stopping, taking a walk in nature, things I love about living here, artwork, helps put me in an intuitive thinking mode. You learn to recognize what it feels like. Opening your heart, just opening your heart automatically helps you shift from an analytical thinking mode to an intuitive thinking mode. You want to switch from an intuitive thinking mode to an analytical thinking mode? Pass judgment on something. Bingo, you're analytical. As designers, you need to do both. You need to know how to switch back and forth between them. This is a method to help you go into the intuitive thinking mode. I'm going to go into some more PowerPoint slides now and kind of shift some of you back into analytical, but I'm going to just pause for a few seconds and just let you float. Okay, float time's over. Now we're going to talk about the three fundamental activities for design, the three universal activities. One is clarify the ambiguous situation, generate a bunch of ideas, select one. But it's not that simple. We don't clarify, then generate ideas, then we pick one and we're done. We never have enough information to effectively pick an idea. We just don't have it. Design projects were always short of information. So we have to go through the sequence. We go down, we generate a bunch of ideas. That gives us more information about what our problem really is, so we can use that to clarify what we're really trying to do. We get into the selection process, we start picking things, we realize more information, we realize stuff, and we have to back and forth and iterate. I talk about here, we may have to iterate hundreds of times per project. For some complex projects, we're talking millions of times to iterate through. There are times when I'm working on a painting. I have a painting, I have a problem with the painting, I see what the problem is. I'll grab a paintbrush, a loaded paintbrush, and I'll step back from the easel, and I will switch between analytical and intuitive thinking many times, back and forth, trying to clarify what is it I'm really trying to do. I see there's a problem, I know there's a problem, but what is it I'm really trying to say? It's an iterative process. Design is messy. It's what makes it fun. Design is messy. If anyone could do it, it wouldn't be as fun. We all design our own stuff. It's fun. Okay, let's look at clarifying an ambiguous situation. There's two things we need to be aware of. First, what's the underlying purpose? Why are we doing this design project in the first place? Why not do it? Why are we doing it? What purpose does it serve? When we clarify these things, it sets us in the right direction. As an engineer, if you don't take time to clarify the purpose, you can end up solving the wrong problem. Successful solution, but you're solving the wrong problem. If you're an artist, you could end up with a painting that says absolutely nothing. And I have a number of those in my studio that I did not clarify what I really wanted to say with a painting. And there's a bunch of color on the canvas, but it says nothing. Next part of clarifying a design project are constraints. All designs have constraints. There's limitations to what that have to be satisfied. One common one is, how much time do you have to put into it? How much money do you have to put into it? If you're an engineer, what's the context? How does it have to be compatible with other existing systems? Big constraints. If you're an artist using acrylic paints, how do you handle a quicker drying time? If you build with layers and using oil paints with a slow drying time, how do you handle that? They require different skills. Do you have those skills? Watercolor. There's problems with watercolor. How do you keep the paint from moving if you have to re-wet the painting? There's all sorts of problems. With art, what are you trying to say? I've painted a number of places around here multiple times, and each painting looks different because each time I've tried to say something different about what I was trying to paint. All right, how do we clarify an ambiguous situation? We know it's ambiguous. What do we actually do? The single most important thing we do is get more information. Just go get more information. If you're an artist, you ask yourself. You get the information internally for the most part. Unless you're doing a project, someone's paying you to do it, or then just don't worry about it. You need to get that input, that information. But most of the time you ask yourself. If you're an engineer, you have to get information outside of yourself. Talk to other people, maybe a literature search, maybe talk to other experts, but you need more information. We get good information by asking good questions. And this is not a trivial thing. How do you ask good questions? Review similar designs. As an engineer, I've done a lot of literature searches, a lot of patent searches to get the information. As an artist, I've gone online and looked at a lot of different paintings. I've taken art history courses. I've looked at stuff, I've been to museums. I try to catch most of the shows here at the Museum of Art just to see what other people are doing. There's a lot of galleries around here. I go into art galleries, not interested in purchasing anything, but I want to see what other artists are doing. It gives me more information to inform my own art. Make and test models. As an artist, I do a lot of thumbnail sketches, little 2 inches by 2 inches sketches of what I'm going to paint before I do it to lay out my composition. And say, does this say it? And I'll do multiple ones, and I will pick the one that I think best expresses what I want to say. As an engineer, oftentimes it's computer models. You develop these fancy computer models, and you just try things to see, does it work? You experiment with that. There's no adage in design, fail fast, fail often. The idea is fail. Make a design decision, build something with the intent of it failing, because it's much cheaper to fail early in a project than late, and you learn so much about it, it's much more likely that later in the project, when it costs a lot more to fail, you have a design that is less likely to fail. The clarifying action requires both analytical and intuitive thinking. You have to go back and forth between them. All right, let's look at an example. You know, there's the Pacific Coast Intermodal Point. They're talking about putting a container terminal up on North Spit here in Coos Bay. Huge design problem. Let's look at some of the questions that people have had to ask as this thing goes forward. Now, all the questions that I will put here as examples, people have already looked at and already have answers to some extent on these, but none of these questions, absolutely none, are answered completely because the project is simply not that far along. Why build it? Why do it at all? What'll it do? Who wants it? What happens if we don't build it? What are the limiting factors that apply to this? What are the limitations that the thing has to work within? What'll it cost? Who will pay for it? These are some of the basic questions for this particular example that can be asked to help clarify what you're trying to do. All right, let's move on to the second of the universal design activities, generate ideas. This is a fun one. What are ideas? Have you ever thought about it? What are ideas? If I ask you to define an idea, you'd probably struggle. Where do ideas come from? We're all very, very good at generating ideas. We do it all the time. But the more we understand about the idea generation process, the more effective we can be in generating ideas. It turns out most, but not all, ideas come from intuitive thinking. So the more effective you are at intuitive thinking, generally speaking, the more effective you are at generating ideas. The thing is, when design, we don't want a lot of ideas. We have to generate a lot, but we don't want a lot of ideas. What we want is an idea, one idea that's really, really good. How do we generate good ideas versus bad ideas? Well, it turns out we don't. We just generate ideas. The key to generating good ideas is to generate a lot of ideas. You generate 10 ideas, you're going to pick one out of 10. Or you can generate 100 ideas. You're going to pick one out of 100. Which one do you think is going to be the best? 1 out of 10 or 1 out of 100? And yeah, the obvious answer here is the correct one. 1 out of 100 is going to be a lot better. The flip side of that is if you generate 10 ideas and have 1 out of 10, that means you're rejecting 9 ideas. If you generate 100 and you pick 1 out of 100, you're rejecting 99 ideas. The time and effort you put into generating all those ideas, you're just going to discard them. Welcome to design. But you want that really, really good idea? Take the time to do the 100. First ideas we generate are generally not that creative. Whenever we start thinking about ways to do things and generate ideas, our first ideas are usually the ones that come, the low-hanging fruit in our heads, and they're usually the least creative ideas of all. When I'm working on a painting project and I see a problem, I want to generate ideas, okay, how can I solve this problem? I'll sit back, I'll have a painting on an easel that I can see, maybe watching TV, working on the computer, sitting there, I just look over at it, what can I do? I generate an idea. Okay, yeah, that'll solve the problem. What I do then is I ask myself, okay, but what else can I do? What else can I do? I'll set that idea aside, think about generate a new idea. And then another idea will come. Then what else can I do? I try to do that a number of times, so I have a lot of different ideas. What else can I do? It's a very good method. I almost never end up picking the first few ideas that come to mind. I always pick one of the later ones simply because they're better ideas. And you won't know that until you know what they are. And you won't know what they are if you pick the first ideas that come to mind. All right. How do we actually generate ideas? If you have a complex problem, the first thing to do is break it down into pieces and don't try to generate one big idea for everything at once. Break it down into pieces, then work each smaller pieces as a separate design project, generate ideas for that. This is a really good one. Defer judgment. When you generate ideas, don't judge them. Just say, okay, here's the idea. Intuitively, you may think, this is not going to work. Don't make that judgment. Just write it down. Because what happens when we start judging, we switch into an analytical thinking mode, and analytical thinking kills idea generation. Just put it down, just put the idea down and don't worry about it. Just, okay, here's the idea, then generate the next idea, generate the next idea. In engineering design, it's very common to run across a very common thought is, okay, you're working on a project, half a dozen ideas, you're good. That's all you need. I was teaching capstone senior design projects with industry-sponsored projects where industry said, here's a design project. I have a team of 4 students. They're working on that, took a year to work on the project. And I had to train them. No, half a dozen ideas is not enough. But I also trained them how to generate ideas. Once they understood that, there was never a project for a very narrow, constrained, industry-sponsored problem. They have this, there's all these constraints and limitations. Every single team that I led with this generated at least 50 ideas. Not 6, not 5, 50. And they ended up rejecting all of them but one. But the ones they kept were very good. Seed ideas. This is a funny thing about intuitive thinking, is that even though it's not sequential, our intuitive thinking is guided by, I'll say biased by, I'll talk about biases shortly, by the context in which we use it. So you want to generate more ideas, pick a different topic. Let's take for example, what are you going to buy at the grocery store? What's your shopping list going to look like next week? Okay, on Monday, there's a random seed idea. I do not want you to put anything red on your plate. Now, how many of you thought about what red could go on your plate? Yeah. Whenever you put that in mind, that's what you think about. Hey, I want something leafy. Okay, you start doing that. Steel ball bearings. What does steel ball bearings have to do with what you can put on the plate next week? It turns out that it's a seed idea. And if you stop and you think about steel ball bearings and just kind of gently think about it and think about the meal next week, steel ball bearings, you'll find ideas coming to mind that you never would have thought about. So feed your intuition with random stuff to help you generate stuff that's truly interesting. Okay, here's an example. These are some of my paintings in the idea generation process. The topic that I wanted to paint, the ambiguous situation, is I wanted to do a series of painting, what does heaven look like? I've researched, I've done studies on different religious traditions, and I looked at what do they talk about, what's heaven like? And how can I express that on paint? One of my painting modes is I paint what I call spiritscapes, paintings from beyond the veil. Not landscapes, not seascapes, but spiritscapes. One of the things that many of these religious traditions talk about is heaven is filled with an incredible light or incredible haunted sound. So, okay, how do I paint light? How do I paint sound? The upper left-hand painting is one way of expressing light. rays come out from a point. Okay, it turns out that the lower left-hand side is one way of expressing sound. Light comes out as rays, sound comes out as waves. And so I have waves coming out as a point, as an idea. Then I thought, how do I put them together where I have light and sound at the same time? And that's what the rest of these paintings are. Just different ways, just different ideas of expressing light and sound together. There's no judgment involved here. I have other paintings, I have other ideas that I've not painted yet. It's just generating ideas without judgment. I see a whole bunch of other paintings I could do. I just haven't gotten to them yet. There's no hurry. There's no judgment. I'm simply generating ideas. All right. The third and final of the universal design activities is select one idea to implement. How do we make decisions? Have you ever thought about that? How do we make decisions? Yeah, you probably haven't thought about it, or you thought about it, but nobody knows how it works. There's a whole decision-making theory stuff. If you study that, there's journals, there's books, there's whole methods of decision-making. Virtually none of them are relevant to design. I'm not going to get into that. What's important is, how do we pick the best design? What is the best design? How do we know what the best design even is? How do we know? One of the key things with the decision process is ask yourself, is it time to actually choose that last idea, or is it time to get more information? Almost all the time in the design process, it's not time to make an actual selection. Almost always, not always, but almost always, defer making the selection, get more information, generate more ideas. Defer, because there's things you can do to help improve design. Probably the single most important reason why designs fail is premature selection of an idea before you've gone far enough in the design process. Premature selection is probably the most significant cause for design failure. So defer as long as you can. If you're an engineer working for your boss will tell you when you have to make your decision. If you're an artist, you've got to come up with your own way of handling that information. Eliminate ideas that are not useful. But don't just eliminate them. See if you can modify them to make them useful. And there's no idea. How do you know if it's useful? Well, remember back when you clarified the project, there's the constraints and limitations. A design is useful if you satisfy those things. It's that easy. Once you've got a good understanding what the problem is, the purpose and the constraints, you know if a design is useful or not. If you satisfy the constraints and satisfies the purpose, it's useful. What if you don't know? Time to get more information, go back and revisit the stuff. Design is iterative, design is messy. Iterate. Update the purpose and constraints, generate more ideas. Okay, how do we actually make the final decision? It's time. We have to choose one. There's no putting it off. There's no deferring. There's nothing. We need one. How do we actually pick that one? It turns out we need to use both intuitive thinking and analytical thinking to do the process, and it's not simple. Analytical thinking, as it turns out, its strength in decision-making processes is separating a bunch of good ideas from a bunch of bad ideas. Analytical thinking, analytical processes, and engineers are generally taught some formal mathematical methods. I taught them that it's good at separating, hey, these ideas are really a lot better than these ideas. And analytical thinking is actually very good for that. But if you've got a bunch of good ideas and they're similar, analytical thinking isn't failure at separating those and picking one of those ideas. They're all good, but which one's the best? It turns out intuitive thinking is best at making that final decision. Once you separated out the good stuff from the bad stuff, our intuitive thinking is better at integrating and synthesizing incomplete information. We actually all can make very good intuitive decisions based on incomplete, limited information because our intuitive thinking mode is very good at doing that. So we need both. Intuitive thinking is very good at synthesizing and making that final decision. We balance the constraints. We buy a car, we finance a car. Do we put a whole bunch of money up front or pay it off and then have no payments or small payments? Or do we pay very little and have a lot of large payments? Well, how much money do you have to spend up front? How much money do you have every month? These are constraints you have to balance in the decision-making process. And the final comment on this, no decision-making process is perfect. Analytical thinking has its value, but it's imperfect and will not lead you to the best solutions by itself. Intuitive thinking is imperfect. It will not help you get or not choose the best solution for you. You have to use both and go back and forth between them. Okay. Example for these three. How do you make a selection process? And the example here, the design project is design your life. Look at your life. Where are you going with your life? Take a look at it. Let's look at some of the basic decision processes. What do you want out of your life? The very fact that you're here at a university says you want something more than you have right now. What's your life purpose? What's your purpose for being here? A lot of people ask that question. What are the constraints? Constraint number 1, your gender. Constraint number 2, your health. Constraint number 3, your finances. Constraint number 4, you go down and down and down and down the list. I'm not smart enough to do that. I'm good at this, but I'm not good. The lists are many. But to design your life, you need to do this. So, generate a lot of ideas. Generate 100 ideas. Don't pass judgment on them, on whether you're happy or not, you like them or not. Just generate ideas. Here are things you could do. And then in the decision-making process, you can sort out, well, which ones really satisfy your purpose? Which ones really do that? Just go through this process. Write them down, generate a lot of ideas without judgment. Look at how you can modify them. Consider them one at a time. Take your time and reflect on them. How do you feel about it? Eliminate the ideas that don't work. Can you modify them? Well, I can't do that because of this, but if I switch and did this instead, okay, go with your heart. Ultimately, for this particular design project, in fact, with most design projects, pretty much all design projects, the final decision is go with the heart. You look at a big multi-billion-dollar engineering design project, you have this option, you have this option. Someone has to make that final decision, and it's going to be above your and my pay grade. It's going to be the guy or girl with the corner office. They will make the decision, and ultimately, their decision will be made by their gut. The CEOs of the world. Ultimately, their final decisions they make is they go with their gut. I feel it's that one. Intuitive thinking, because intuitive thinking is best at processing incomplete information. We've done all the analytical thinking, we've done all that analysis. The final decisions are made with intuition, then just do it. Okay, time for another painting, time to get away from all this stuff. Painting of Crater Lake. You know, it's kind of blurry on this, but take a breath. I'm going to wrap up fairly quickly here, go through these fairly quickly. Take a breath, make sure you're back thinking intuitively analytical, the intuitive mode. Cognitive design, cognitive enhancement in design. Big fancy words, just basically means what can you do to make yourself a better designer? Incubation. Take a break. Don't just design straight through. Do something and do something totally different. While you're doing something totally different and unrelated, we're not even thinking about it consciously. Unconsciously, you're working on it and solutions will come. Sleep on it. You've heard that phrase. It turns out it really does work. If you have a design project and you can sleep, particularly REM sleep, rapid eye movement, when you dream, oh, there's dreams. It really does improve your designs, and the studies have shown this. Transition to sleep, hypnagogia. Thomas Edison, the big inventor, he would have big technical problems, so he'd sit down in a chair, hold a couple steel balls in his hand, and take a nap in the middle of the day. His body would relax, his hand would relax, the steel balls would drop to the ground and wake him up. He often had solutions to his design projects right there in his mind. He thought about it as he took his nap, the balls woke him up, and there was a solution. It was right there. And yes, it does work. The painter, Salvador Dali, would do the same thing, only he had keys in his hand. Take a nap, relax, keys would drop, wake him up, and he would paint the images in his mind. Surrealistic. That's where he got his ideas, as he got them in that transitional state going to sleep. Meditation. Turns out there's two basic forms of meditation. There's an active meditation involving mindful meditation, and there's passive. I could go into great detail on the terms, the advantages and disadvantages. I'll simply say that from a design perspective, meditation will help you develop your metacognition. It's very useful for that. Okay, design biases. We're all biased. Every one of us, we have biases. I have biases, you have biases. Common biases, particularly for design, familiarity. We're biased toward things we're familiar with, and we're biased against strange things. Confirmation bias. Whenever we encounter new ideas, we generally interpret them in a way that confirms what we already believe. We hardly ever take new information and look at it and go, wow, what does this all mean? Our first impression is to interpret it in a way that confirms our preconceived beliefs. And yeah, it's real. We're biased in our thinking mode. Intuitive thinking mode is biased by the context we use. I talked about seed ideas. It turns out if you don't use seed ideas that break away from that, the ideas you'll generate with intuitive thinking will be biased. Analytical thinking is biased by the sequential process that analytical thought goes through. You cannot get out of the box with analytical thinking. You want to think outside the box, you must use intuitive thinking. Solar flares. Any of you see that coming? Develop the ability to do that yourself. More biases. It turns out, are we creative? Are we conservative? We have a bias one toward the other. More conservative people tend to be more biased toward analytical thinking, and it's more difficult for them to get involved with intuitive thinking. Highly creative people are more biased toward intuitive thinking, and oftentimes they have difficulty doing analytical thinking. So be aware of your biases so you can address them. Feelings can bias us. If we're in a good mood, we tend to be more creative. We tend to accept more risks on the design. If we're in a bad mood, we tend to be more conservative. Yep, look at your mood. Turns out that if our design decision personally impacts us, that bias gets reversed because we tend to choose a path that sustains good feelings and alters bad feelings or bad mood. The way we address our biases in design, or we balance our intuitive thinking and analytical thinking. We balance them. Metacognition. All right. Summary. Design is universal. Well designed. Use metacognition. Recognize whether you're doing intuitive thinking, analytical thinking. Learn how to switch back and forth between the two. Practice the 3 universal design activities. Clarify, generate, select. Use cognitive enhancement methods. Balance our biases through both intuition and analysis. Now, here's the final comment, which is going to be coming out of the blue because it's not something I mentioned at all in the presentation. But it's something that if you would do this, or if you were this type of person, you're a much better designer than people who don't do this. It's one of those characteristics of highly effective designers. And I'm not going to get into the details of why. Be curious. People who are curious ask themselves questions about anything are more effective designers. Ask questions. Ask questions. Ask questions. So ask questions. Yeah, let's let the lights come up first. Okay, yeah. Oh, we got a microphone coming because we have a lot of people online.
Hello. Oh, okay. What is like the main method that you use when you talk about being able to like consciously switch between the different types of thinking when you're designing something?
Practice. In my book, I go through a lot of different examples to how to generate an intuitive thinking mode, how to do an intuitive thinking mode. There's just not time to do this, but it just practice. Do things that generate analytical thinking and look at how you feel about it. What does it feel to be an analytical thinking mode? And then switch to intuitive thinking. How does it feel? And with practice, it becomes natural. I can switch back and forth now just at will like that. Oh, analytical, oh, intuitive. It just practice and it just becomes second nature. And then you just have to consciously make sure you do it.
Thank you.
Those of you who are remote, my understanding is you can type in your questions and they will be transferred over to me and I can get answers to you as well. Go ahead.
So I came in like 5 minutes late. I'm actually kind of curious about your background and how you growing up in your childhood, you had your interests of art and then engineering as well. Why did you kind of go down that path? Because I missed your background. And sorry, sir, what's your name?
John Reese.
Nice to meet you.
Okay, I actually started out almost exclusive in an analytical thinking mode with very little intuitive thinking. And as I lived my life, I found it too constraining. So I started getting involved. And now that I'm retired, I'm probably more in the other end of it. I'm involved with music, both singing and keyboard. I write songs. I'm an artist, do painting. Writing, I have several books in print. Well, one of them is this one. I have another book in print. It's just something that I saw my life was too limited when I was just doing analytical thinking. So I got involved with the arts more and more, and it just brought balance into my life. So that's really what I would say is find balance with your life.
I appreciate everything you've brought up in this talk. One of the things that I think about when doing design or kind of intuition of new projects, I find myself I get bogged down a lot in analytical stuff because I also get bogged down in, okay, if I'm designing this, how am I going to make it as accessible for everybody as I can? Because I have physical limitations and there's a lot of people in my family that have medical situations that I may be designing something that's designed to be as universally applicable as it can be for, say, a particular project or a particular application, but then trying to figure out where to balance that, the sort of the continuing constraints on accessibility for the various audiences that you may be designing for, depending on the project. So I was curious how those accessibility constraints kick into some of the design principles and the application thereof that you discussed.
Well, one of the first things I talked about is design of the application of design. The things you mentioned fall under the category constraints. That's general, but for the very specific issues you raised, that depends on what you're designing for. And that's not universal. So you have to apply the universal ideas, the practice of what are the constraints, and then use those as your limitations as you go through your design process. You mentioned a very important design issues, very, very important design issues. And I applaud your working in that area to address those issues. Is very important. I'm not sure if I've answered your question.
Online, we have Janet that made a comment of excellent point, designing more inclusively. And then we had a question from CG Logston that said, you mentioned failing fast and often. Could you say more about how creatively approaching failure can help you as a designer?
Okay, the fail fast, fail often is basically a way of getting more information. You try something. I have many paintings in my studio that are failures, but I learned from them. A lot of the paintings I showed you on painting heaven, painting the light and sound of God. A lot of those, when I get into the selection mode, I will say these are failures because they're not addressing what I really want to say. Fail fast, fail often. But I don't care if they're failures or not, because I learn from each one of them. So try something. I talked about modeling ideas. Modeling is the best place in the world to fail. Because if you can fail, you will learn stuff that you never possibly could have learned without that failure. So build failure into your design process. I do, because I learned so much from the failure. When I come around for my next iteration or the next iteration or the next iteration, I am so much further along in the process that my next designs afterward are so far superior because I failed and I learned from my mistakes. To err is human. For design, it's mandatory. Learn from your mistake. Make the mistakes, learn from your mistakes, and do it as soon as you can. Fail fast, fail often, fail early when it doesn't cost a lot.
Anybody else? Oh, 1 second.
And for those you listening online, my understanding is this is going to be recorded with YouTube's being recorded. So this presentation will be available to you afterward. You're going to listen and listen and listen and guaranteed to put you to sleep. Yes, go ahead.
So the sleep transition state made me think of something I've heard of as called shower thoughts, which I've had many, where the thing that kind of makes me wonder is, I understand that it seems like the end result of the shower thought is an analytical process, but it's coming to you intuitively. So is there a connection between analytical thinking and intuitive thinking? Because I feel like the final idea that comes to my mind that's answering a question in a result is very analytical, because it's afterwards I realize seems like a very obvious stepwise progression, but I had to come up with it when I wasn't thinking about that process.
Two comments. First of all, when the metacognition, when I switch back and forth between analytical thinking and intuitive thinking, sometimes I'm doing it within seconds. I can stand back with a painting, a loaded paint brush, and stand back there intuitive, analytical, intuitive, back and forth multiple times within seconds. So you talk about the shower thoughts. You're probably doing both. You're just not recognizing you're doing both. Second comment is there is a process that many of us, we all do, many of us are already doing, and it's the only process I really know of that simultaneously engages both the executive control network of the brain and the default mode network of the brain, where we're simultaneously doing analytical and intuitive thinking. Not one and the other, not one and the other, but we're doing them simultaneously. And that process is called improvisation. As a musician, as a jazz background, I'm improvising a lot. As an artist, an artist called intuitive painting. But it's what I do is not straight intuition. I do have, there's an analytical framework that I have, and I'm going down in the back of my mind subconsciously, the rules of art, which are really aesthetic principles that people have found make a painting, say, aesthetically pleasing. There's these principles, and I can tell them what the art students are taught them. But it's the point where during the improvisation stage, you can do them both simultaneously. Sometimes I just do it where maybe a few seconds, one, a few seconds in another. And other things, I could be in one mode for minutes. At this point in my life, with the experience I have in design, it's rare that I'm in one mode for more than a few minutes at a time. Even when I'm plein air painting over at Cape Arago, I'll be up there Tuesday morning, I'll be painting. I do a lot of intuition with the paintings, but even then I'm always back and forth analytical. And I have enough experience, enough practice. And that's another thing, just practice. That's how you master. Just practice. Be aware, practice, and it becomes second nature.
Thanks so much. I was hoping that maybe you can shed some light on the benefits of teamwork or in design. Some of the people that I've seen design things or heard about design things, certainly painters, they seem to be working alone, or maybe they just don't credit people. But often there's engineering teams, and they have, they seem to value teamwork. So wasn't sure if you've done some research on teamwork in design.
I have a whole chapter in my book on teamwork, design on teams, which I did not talk about at all. Just a few brief comments. With regard to idea generation, the biggest mistake teams can make is group brainstorming. Group brainstorming is ineffective. A better way to generate ideas is for people to generate ideas all by themselves, then come together and share and bounce off each other. The details, I go into the book. I'm not going to take the time to do that here, but that's one of the things you need to know how you're going to make decisions. Is it going to be consensus? Going to be vote? There's a lot of mechanics, organizational mechanics of teams that need to be worked out in advance to work about that. Sometimes the team comes up with something and then you just pass it up the food chain and let the person in the corner office make the decisions. There are different processes with design when you come into teamwork. All these things I talk about still apply, but you have interpersonal factors that are huge that you need to address when you design on teams. Did that answer your question? Okay.
My question is similar to his, but not teamwork. I'm just thinking early on in design, seeking out criticism to maybe sway you, or just, for example, say like, I'm not saying that'll never work because of a simple reason you didn't
Okay.
realize.
In art, there's something that's called a critique. When I do my weekly plein air painting with my group, when we're done after painting a couple hours, we'll have lunch, we critique. It turns out studies have been done that when you engage in critique, you're a better designer. When you engage as an artist, if you engage in listening to critique of others and critiquing others yourself, you develop those skills to recognize what's working, what isn't working. So if your purpose of critique early on is to get more information, yes, do it. If the purpose of critique early on is to stop ideas, then it's bad. Because early in the design phase, you do not want to stop any ideas. You want to keep everything on the table because I'll give an example. It's in the book, one thing I ran across. Here in the Pacific Northwest, lots of logging, major industry. There's lots of mountains where people want to log and they can't build roads because the mountains are too steep. Apparently, this logging company, people were sitting around the table trying to say, how do we get these logs out? We can't build roads. And reportedly, one of the people sitting at the table said, what do you want us to do? Have green men from Mars come and lift them up? That's not a very effective solution. But it led to the idea of lifting logs out with helicopters. And that is an effective solution. So you don't want to use critique to stop ideas early on. You want to use critique to get more information to lead to this and lead to this and a trail of breadcrumbs. You don't know what trail that's going to take. But that trail of breadcrumbs will lead to a better idea. So with critique, I do critique. It turns out I'm a better artist because when I critique other people's art, I'm practicing my analytical thinking skills regarding art, and it helps me critique my own work better. When I look at my own work, I'm better at, and this is an analytical technique, but I'm better at doing it when I critique others. And when I listen to others, they point out things that I never saw. The goal of critique early on is to get more information. And in that context, it's highly effective. Don't use critique early on to stop ideas, to say, no, it won't work. But if you say, okay, don't work, why won't it work? Get the more information. Why? Help clarify the situation. That's when it's important. That's when it's useful. Any other questions? Oh, got one over here.
I had one because it kind of ties into what I often do scientifically, and then also when I'm thinking about various design projects and creative design projects. There's kind of a double-edged sword that I deal with a lot. It's going back and not reinventing the wheel and kind of building off of the successes of other people, but then it's also not getting bogged down into the we've always done it this way and it's always worked this way, so therefore it has to continue to always work this way. How do you sort of balance that kind of learning from previous execution, but not getting so pigeonholed into doing things the same way you've always done them and leaving yourself open for other ideas and other ways to go around things?
In the design field, what you talked about is most commonly referred to something as design fixation. You're fixated on how it was always been done. You're fixated on this, can't think outside the box. The most valuable thing you can do, well, before you get into the valuable thing you can do, talk just a little bit more about what's going on. There's the balancing that one of the constraints is compatibility. If you're building a new engineering system or engineering device, it has to be compatible with everything else in the context it's going to be used in. That's a constraint. You have to honor that. How you think outside the box, if you're dealing with thinking outside the box on a team, you have to, it requires interpersonal skills to work that out. But as an individual designer, my recommendation is more intuitive thinking, generate more ideas, knowing that all of your ideas but one are going to be discarded. But go through the process. And as you do that and you generate more and more and more ideas, you go through the process, then you'll start finding the better balances between the two. I would say the single most important thing you can do to balance, this is the way we've always done it, versus we need something new, is get a lot of ideas there in the middle. Then you'll find something that, okay, yeah, that, and ultimately, all decision-making processes are imperfect. If you satisfy the constraints, it's a successful design. It may not be what you'd like, but if you satisfy the constraints, you've met the purpose, it's a successful design. So that's the goal. And you do that by understanding what the real problem is. Most of the time as engineers with technical problems, we're not told what the real problem is. We're told what the symptoms are. And that's a big mistake to solve technical problems, is address the symptoms. You need to dig deeper until you know what the underlying problem is. And once you understand the underlying problem, then you can come back and come up with a solution that, oh, by the way, these symptoms are now gone. Okay.
Anybody else online or here have any questions? And if for some reason you don't get your question answered today, feel free to reach out. I have some of my cards up here on the table and I can get you in contact with Dr. Reese. So.
Be curious.
Just want to say thank you to everybody for being here. We had quite a few viewers online, and then some of those were watch parties. So I don't even know how many people were actually there. So we had actually quite a few people here. I'm really excited. We typically don't start the lectures this early in the term, but this tells us that they actually are okay during this time as well. So I was pretty excited. This was an awesome talk. I was like blown away by a lot of the things. I knew it was going to be cool, but I didn't quite think it was going to be this cool. So, so thank you very much. And thank you all again. If you didn't sign in, if you would, this does help us kind of track the attendance of these types of talks to keep providing them free to the community. Just ask to leave your name and email if you would like, or if you just want to leave your name, that's okay. If you're a student or employee, just leaving your ID number is helpful as well. So with that said, thank you.
I'll be here for a few minutes afterward to answer any questions you might have for one-on-ones.